Greetings. Welcome to the coolest lesson on measuring segments. So, the first thing we're going to talk about is this ruler postulate. The ruler postulate is that every point on a line, no matter where on this line it is, can be paired with a real number. This makes a one-to-one correspondence between the points on the line and the real numbers. The real number that corresponds to a point is called the coordinate of the point. So basically what that means is any point along here, we can give it a coordinate. So why is that helpful? Because it allows us to talk about the distance of a segment. And the way we find the distance of a segment is we subtract the coordinates of the endpoints and take the absolute value. And it doesn't matter what order you subtract them in because we're taking the absolute value, and you'll see why in just a minute. So what is ST? Now when there's no line over it, if there was a line over it, it would say, what is segment ST? And then you would say, well, it's the segment that has the endpoint, one endpoint S and the other endpoint T. But when there's no line over it, what that means is, what is the length of segment ST? So what is the length of segment ST? We can use the ruler postulate to say the coordinate of point S is -4, and the coordinate of the point T is 8. And then we can use our definition of distance to subtract the coordinates and then take the absolute value. -4 minus 8 is -12. Absolute value of -12 is 12. But what if you wanted to do it in the different order? We would have to call it segment TS then. And the length of segment TS would be the coordinate of T minus the coordinate of S, which is -4. So that's 8 plus 4. That's absolute value of 12, and the absolute value of 12 is 12. You get the same answer. So pause it and see if you can figure out the length of UV and the length of SV on the number line above. For UV, that's going to be the absolute value of the coordinate of U, which is 10, minus the coordinate of V, which is 14. 10 minus 14 is -4. And the absolute value of -4 is 4. And you can verify just by looking at the graph that U and V are 4 units apart. 2, 4. How about the length of SV? That's going to be the coordinate of S minus the coordinate of V. The coordinate of S is -4. And the coordinate of V is 14. So, -4 minus 14 is -18. So, the length of segment SV is 18. The segment addition postulate. If you got 3 collinear points, and B is between A and C, then we can say that the length of segment AB plus the length of segment BC equals the length of segment AC. Seems to make sense, right? So if EG is 59, so the whole way here is 59, what are the length of EF and the length of FG? So what do we know? We know that EG is 59, the length of EG is 59, the length of EF is this expression 8x minus 14, and the length of FG is the expression 4x plus 1. We need to find the length of EF and the length of FG, which means we're going to need to find out what x equals. And we're going to use the segment addition postulate to write a fantastic equation. The segment addition postulate says that the length of segment EF plus the length of FG equals the length of EG. Now we can just substitute those things that we know. I know that EF is 8x minus 4 and FG is 4x plus 1. and I know that EG is 59. Now I can simplify the left side here by combining like terms. 8x plus 4x is 12x. Negative 14 plus 1 is negative 13. Then I'll add 13 to both sides. Get 12x equals 72. Then divide both sides by 12. And you get x equals 6. Okay, so are we done? Not quite, because we want to know the length of EF and the length of FG, not just what the x value is. So what do we need to do? We need to use the value of x to find those lengths. We're going to substitute a 6 in for x. So EF was 8x minus 14. I'm going to substitute a 6 in for x. 8 times 6 is 48, and 48 minus 14 is 34. For FG, the expression for FG was 4x plus 1. Substitute a 6 in for x. 4 times 6 is 24. 24 plus 1 is 25. So, see if you can do number 2. Alright. JL is 120. So 120 is the whole way from J to L. What are JK and JL? Well, the segment addition postulate tells me that JK plus KL equals JL. And I'm abbreviating here. I don't want to say the length of segment JK plus the length of segment KL equals the length of segment JL every time. You know what I mean, right? With no line over it, it means the length of the segment. So JK is 4x plus 6. KL is 7x plus 15. And JL is 120. I'm going to combine like terms. 4x plus 7x is 11x. And then 6 plus 15 is 21. Then I'll subtract 21 from both sides of the equation. And we get 11x equals 99. Ran out of room. So we're going to divide both sides by 11. We get x equals 9. But we're not done because we want to find out what are JK and KL. So the length of JK was 4x plus 6. And the length of KL, 7x plus 15. And I just need to substitute a 9 in for x. 4 times 9 plus 6. So that's 36 plus 6. And JK equals 42. KL, 7 times 9 plus 15. KL, that sounds like Superman's brother or something. My name is KL. 7 times 9 is 63. And 63 plus 15 is 78. So there is my answer. The length of JK is 42, and the length of KL is 78. And if we're awesome, we add those together, and we should get 120. And it works. Alright, so when two numbers have the same value, we call that equal. If two segments have the same length, we call that congruent. And you write it equal sign with a squiggly on top. That means congruent. Okay, so congruent just means that congruent segments means that two segments have the exact same length. So this means that the length of segment AB, if the length of segment AB equals the length of segment CD, then we can say that segment AB is congruent to segment CD. And it works the other way too. If you have two congruent segments, if segment AB is congruent to segment CD, then the length of AB equals the length of CD. So if these are both 1 inch, then we have two congruent segments. And this little mark right here, whoosh, if you put that on two segments, that means those two segments are congruent. So if you see two segments and they have these little hash marks on them, even without saying it in words in the directions, you can already know that they're congruent segments. So this is how you make the notation in a picture of congruent segments. Question: are segment AC and segment BD congruent? Let's see, here's segment AC, and then segment BD goes from here to here. Well, are they congruent? Let's use the definition of distance. Segment AC is the coordinate of A, the absolute value of the A coordinate minus the C coordinate. C looks to be at 5 here. -2 minus 5 is -7, and the absolute value of -7 is 7. What about segment BD? The coordinate of B is 3. So we're going to do 3 minus 10, and that's -7, and the absolute value of -7 is 7. They have the same length, therefore the two segments are congruent. Alright, so use this diagram to figure out if segment AB is congruent to segment DE. And go ahead and pause the video to do that, and hit play when you're ready for the answer. Okay, so is segment AB congruent to segment DE? The length of segment AB is the absolute value of the coordinate of A, which is -2, minus the coordinate of B, which is 3. That's the absolute value of -5, so the length of segment AB is 5. The length of segment DE is the absolute value of the coordinate of D, which is 10, minus the coordinate of E, which is 14. And that is the absolute value of 10 minus 14 is -4. The absolute value of -4 is 4. So these two segments have different lengths, so they're not congruent. No. Segment AB is not congruent to segment DE. To find AC, the length of AC in problem 3, suppose you subtract -2 from 5. Do you get the same result, and why? The answer is yes, you get the same result, but we would technically call it segment CA. 5 minus -2. So we're doing the C coordinate minus the A coordinate, and that's the absolute value of 5 plus 2, and the absolute value of 5 plus 2 is 7. So what we get from that is it doesn't matter which direction you measure in. You can measure from point A to point C and you'll get 7 units, or you can measure from point C to point A and you'll still get 7 units. What's a midpoint of a segment? Well, the midpoint is the point that divides a segment into two congruent segments. That's the definition of a midpoint. A point, a line, a ray, or some other segment that intersects a segment at its midpoint is said to bisect the segment. Bisect means cutting it into two equal parts. Bi means two, sect means cut. So bisect means to cut it into two equal parts, meaning you're cutting it into two congruent segments. So whatever that line or point or ray is, we can call that the segment's bisector. So B is the midpoint of AC, and the line L is a segment bisector of segment AC. So we know that Q is the midpoint of segment PR. What are PQ, QR, and PR? I'm going to make a little notation that says this is congruent. PQ is congruent to QR. We need to find out what X is so that we can plug in and find all these segment values. Well, how are we going to find out what X is? We know that Q is the midpoint, so PQ is congruent to QR. That means the length of PQ is equal to the length of QR, so we can set these two expressions equal to each other. Length of PQ equals length of QR, definition of a midpoint. So I can set these two expressions equal to one another. Now I can subtract 5x from both sides of the equation, and I get x minus 7 equals 1. Then I can add 7 to both sides, and I get x equals 8. So I know what x equals now. I just need to substitute that in to 6x minus 7 to find the length of PQ, and 5x plus 1 to find the length of QR. So I'm going to substitute my 8 in for each x value. 6 times 8 and 5 times 8. And I get 41 for each value. And that makes sense because they're supposed to be equal. So how do I find PR? Well, the segment addition postulate tells me that I can add these two together and get the length of PR. So I'm just going to add 41 plus 41, and segment PR is 82 units long. So pause the video and see if you can figure out this problem down here. So for A, is it necessary to substitute the 8 in for x in the expression for QR in order to find the length of QR? And the answer is really no, because once we find PQ, the definition of a midpoint tells us that PQ is the same as QR. So we can just go from here straight to there. So now for B, U is the midpoint of segment TV. And so what are the lengths of each segment? TU, UV, and TV. Well, these two segments are congruent, so I can set 8x plus 11 equal to 12x minus 1. I got 8x's over here and 12x's over there. I'm going to subtract the 8x's off of this side. So that I have 11 equals 12 minus 8 is 4, so 4x minus 1. Then I'm going to add 1 to each side, and I get 4x equals 12. Look, life's getting easier. We just need to divide both sides by 4, and then we know that x equals 3. But we're not done because they asked us what's TU, what's UV, and what's TV. Alright, now this is going to be easy because all we have to do, we only have to plug x in once. So I'm going to plug x into the expression for TU. TU is 8x plus 11. So that's 8 times 3 plus 11. So TU is 24 plus 11. TU is 35. That means that UV is also 35, and that TV is 35 plus 35, 70. There's the answer. Alright, hope you had a good one. Let me just tell you real quick before you go that the secret code word is Chicago dog. Bye. Talk to you later. Eat a carrot.